Okay, the 3.3 quick check. I'm going to go through this quickly. And we say, oh, here's the KSP of calcium carbonate. Okay, that's a 1-to-1 compound. So from my shortcuts, and I'm going to do my shortcut, I know that the KSP is the solubility squared. So in pure water, then my solubility is simply going to be the square root of 8.7 times 10 to the negative 9, which comes out to be 9.3 times 10 to the negative 1, 2, 3, 4, 5, 10 to the negative 5. Now, if I were to try to dissolve calcium in a solution, now that's my solubility, by the way, that's S solubility. Because calcium breaks up to be one, calcium carbonate breaks up to be one calcium and one carbonate, then this also equals S, so the calcium ion concentration is the same answer, 9.3 times 10 to the negative 5 molar. Okay, sometimes if I was doing like lead chloride, chloride would be double the value of S. Okay, if I want to do it for calcium carbonate dissolved in sodium carbonate, I have carbonate ions in common, then it's a slightly more complicated. I have to do an icebox. And in my icebox, I'm going to find out that my final value, I'm going to have S, and I'm going to have 1.0 times 10 to the minus 3, okay, plus S. And it's a 1-to-1 compound, so these are going to be multiplied, equals 8.7 times 10 to the minus 9. So if I go through and do that problem, I'm going to assume that S is small enough to ignore. So all I really have to do is divide both sides by 1 times 10 to the minus 3. So I'm going to see that my solubility, which is going to be my calcium ion concentration, is going to come out to be 8.7 times 10 to the negative 6. So I'm not surprised that the solubility in calcium carbonate is smaller than the solubility in pure water, okay, because I don't have that common ion that's messing things up. Okay, that's that first part. Okay, second part, effects on solubility. Okay, again, we're looking for which of these, will it increase, decrease, remain the same in the following solutions. If I had calcium carbonate, okay, then I'm going to get calcium ions and carbonate ions. In the first set here, if I have HCl, the H's are going to react with my carbonates, remove them, that's going to drive it forward. Okay, so that's going to increase my solubility. If I have calcium nitrate, I don't care about the nitrate, I do care about the calcium. Okay, the calcium ions, if I increase my calcium ions, then that is going to drive the reaction backwards, okay, toward my solid, which means it's going to decrease my solubility. If I have sodium chloride, well, sodium, if it does anything, it'll react with the carbonate, but that's going to be soluble. Chloride and calcium would also be soluble, so sodium chloride is going to have no effect whatsoever on my solubility or on this equilibrium. And the last one, sodium carbonate. Again, I don't care about the sodium, but the carbonate, if I increase my carbonate ion concentration, that's going to drive my equilibrium backwards, which means it's going to reduce my solubility. So anything that would remove these ions would increase my solubility. Anything that increases those ions decreases my solubility. The last part here is pH dependence. And so we are talking about anything that has a negative ion from a weak acid. If you add acid to it, that will form the weak acid that will remove the ions from the right side of my equation and drive my reaction forward. So let's eliminate anybody we know comes from a strong acid. So PbCl2, that's HCl, strong acid, so that's not going to be there. CdBr2, because HBr, that one is going to be eliminated. Okay, I can see this one here, zinc chloride, because I know that HClO3, that's on my strong acid list. AgI is a little bit more tricky, okay, because AgI, we do have the weak acid AHI, okay, so if I were to add HCl to that, certainly the H would not affect the iodide concentration, but chloride is something that would precipitate with AgCl. So the chloride could have an effect on this solubility in that if the AgCl is less soluble than AgI, that would actually tend to make this more soluble. So I just looked it up, and for AgI, the KSP is silver iodide, 8.5 times 10 to the minus 17, and silver chloride, the value is 1.8 times 10 to the negative 10. So silver iodide is less soluble than silver chloride, so putting in HCl is going to have no effect on that one at all. Okay, all the rest of those, the MgS, S comes from the weak acid H2S, the weak acid H2SO3, very, very weak acid water, okay, weak acid HF, and weak acid H2CO3. So all of these five, these would all be dissolving better in a 0.1 molar HCl solution. And that's the quick check.